Hello, I'm Valerie, and this is my Physics Lab 2 report. In this lab experiment, which is similar to Lab 1, we are looking at the effects of charged U-tapes on one another. However, instead of viewing the excess charge as a point charge, we are observing it as a charge that is evenly distributed over the surface of the tape. The goal of this lab is to create a computational model of the experiment and to depict the electric fields and the different forces at play. Then, we also wanted to create a simulation in the program which allows us to calculate the electric force exerted on the top tape by the bottom tape. By the end of the lab, we found that the electric force exerted is 1.96231 e to the negative 3 newtons. When conducting the experiment, there are a couple fundamental physics principles that we needed to understand. This includes Newton's second law, which discusses the relationship between force, mass, and acceleration. Additionally, we also kept in mind the conservation of charges and the law of attraction, which states that like charges repel while opposite charges attract. There are also a couple assumptions that need to be made. I assumed that each U-tape had the same charge magnitude and that the charge was evenly distributed along the tape. Next up, we'll be talking about the experimental design, which is very similar to that of Lab 1. I started off by creating two U-tapes by quickly peeling off the upper piece of tape from the lower piece of tape as indicated in the top right diagram. Then I placed one horizontally between two bucks, and I carefully brought the second tape closer and closer to the first one until I saw the interaction from the charge of the tape causing the top tape to push upwards. We see this upward movement because both tapes have a positive charge, which we found in Lab 1, and following the law of attraction, like charges repel. Once the experiment was completed, I collected the data, which goes as follows. The length of the tape was 20 centimeters. The mass of the tape was 2 times 10 to the negative 4 kilograms. The distance between the two tapes was 0.03175 centimeters. The excess charge on the tape was 2.2537 e to the negative 8 coulombs. Then, using the data collected from the experiment, I was able to use GlowScript to create the line charge model shown to the right. Now let's take a look at how the model was constructed. To start, I initialized some basic physics constants, the value of the mass of the tape, and the distance found between the tapes. Then, I imported the function to create the electric field from Lab 0. There is also the function called the line charge, which is used to create the visual display of the tapes, which is represented by multiple spheres used to represent the end segments of the line charge. Then, we call the line charge function twice to display the two tapes in even-sized pieces represented by the red and blue spheres. These factors are essential in setting up for the calculations and initialization of the electric field model. Once all the setup was done, I used a for loop to create green arrows starting at the position of each of the red spheres and extended up to represent the electric field at the points. To do this, I used the nested for loop to calculate the E field as well as the electric force at the sections of the top tape due to the sections of the bottom tape. More specifically, when calculating the E field at each point, I called the function E field with the source location at the specific section of the bottom tape and the observation location at the current section of the top tape, then added that to the net electric field for the section of the top tape. Then I also calculated the electric force at that specific section and added it to the overall net electric force on the top tape. Finally, I created two arrows. The white one is used to represent the electric force vector, which has the magnitude of the net E field on the top tape. The yellow one is used to represent the force of gravity on the top tape, which has a magnitude of mass times gravity. Using these calculations, I found that the magnitude of the electric force was 1.96231 e to the negative 3 newtons. And as you can see, it is equivalent to the gravitational force. In Lab 1, we conducted a calculation of a similar experiment with one key difference, the use of a point charge instead of a line charge. If you look at the two results, the point charge calculation revealed an excess charge of 1.48242 e to the negative 8 coulombs, whereas the line charge found an excess charge of 1.96231 e to the negative 8 coulombs. This difference is because in the first model, we perceived the excess charge is coming from one singular location, and in the second model, it accounts for the contributions of charges along the entire tape. To conclude, the line charge approximation is more likely to be closer to the actual charge of the tape because it has a more accurate representation of the experiment with the long piece of tape represented as a line.